Here's your 5 a day. And here are the answers. Okay, so today's lesson is on graphs of sine and cosine. So to start off with, in your books, I'd like you to copy this table. You can do it all the way across your page. And then either from memory or using your CAS, I want you to fill in each of the values. Pause the video while you do that. Okay, so you should have had for sine theta, this is where it equals 0. It's got 2 maximum points, 2 minimum points for this domain. Its period is 2 pi, so that's how long until it starts repeating itself. Its amplitude is 1, that's how tall a wave is. Amplitude is always positive. Its domain we were given up here in the instructions, that's negative pi to 3 pi. The range is from negative 1 to 1. For cos, we've got these points where it's equal to 0. We've got these 2 maximum points, these 3 minimum points. Period is also 2 pi, amplitude is also 1. The domain and range are also the same. So we're going to be having a think about transformations of sine and cosine graphs. For today, just dilations. So when we go from the graph of y equals sine theta to the graph of y equals a times sine theta, it dilates the graph by a factor of a from the x-axis. It's affecting the y values. So if this is our base graph, our y equals sine theta, graph of y equals 3 sine theta, all of the y values get 3 times as big. So it stretches up and it stretches down. If I have the graph of y equals a half sine theta, all of the y values get half as big. Note that I have adjusted the scale on my y-axis accordingly. Now, if a is negative 1, the graph of y equals negative sine theta, that reflects my original graph in the x-axis. All of the y values swap sign. That looks like this. Now, interestingly, if we consider the graph of y equals sine of negative theta, we know that that gives us a reflection in the y-axis. And so it actually gives us the same graph. For cos, same idea. When I multiply it by negative 1, reflect in the x-axis. But cos of negative theta, a reflection in the y-axis, actually looks like this. It's the same as the original graph. So when we're multiplying the theta rather than the whole sine theta, it dilates the graph by a factor of 1 over a from the y-axis. So we have a horizontal stretch or squash going on. So y equals sine 2 theta. That means that we have the same set of y values for half of the theta values. So where I just had a single period from 0 to 360, I now have 2. If I have sine of theta over 3, I've got the same set of y values for triple the theta values. So my graph stretches out, so my period is 3 times the size of the original. Now, in general, and I recommend you write this down, for y equals a sine n times t, the amplitude is a, the period is 2 pi over n. And similarly, for y equals a cos nt. Okay, using that, I'd now like you to do questions 1 to 13 from 6D and ask your teacher if you have any questions. Thank you.